Hello, I am Anthony Atkinson.
And I'm Marco Riani.
We would like today, in discussing our exciting new book about robust regression with three other co-authors, we would like to talk about an example from chapter 4.
This dataset is called bank data. Let us load this data and let us see what is the response. The response is the profit that the bank has achieved from each of its customers.
However, the bank would like to know how this profit has arisen, what particular activities are profitable, what particular activities are not.
Activities can be shown in the description, and these are the activities, are at least the 13 activities. Then the response is the profit loss over a particular year. And here you have the number of instances. The number of instances of X7, number of instances of X8 or X9. Here the values of the explanatory variables are integer, are positive integers, or you can also have a lot of zeros.
In fact, if you look at this matrix, there are large numbers of zeros in all columns.
We start with an analysis of the minimum deletion residual.
So we fit model by least squares using the forward search.
So on the x-axis you have the subset size, then also shown are the confidence bands, and the red dashed line is 99.999% confidence band.
So if there are no, if the data are homogeneous, it's unlikely that this trajectory would go outside. However, as we see just after m is 1600, it moves up vigorously.
Finally, it is worthwhile to notice that this plot has two colors, the red colors and the blue colors. The red colors is associated with the residual which is positive. On the other end, the black is associated to the entry of units which have negative residuals. The prevalence of red over blue suggests that in the final steps you tend to include into the subset observations which have positive residuals. Now we move on, and we analyze the monitor residual plot. In this monitoring residual plot, you can see that the trajectories of the residuals seem to be quite stable. Then there are some large outliers. And then from a particular point here there seems to be a change in the residual. For example, look at this trajectory. This trajectory is as a residual which is completely in agreement with the rest of the data, and then around 1630 and 50, then there is a change in the structure of the residuals, apart from the presence of these large 6 outline observations. Well, if you now show the plot, the y-x plot of the y against the 13 explanatory variables, you can see that the 6 outlying units have large values of y.
You'll also see that there is a 7th blue one, which we didn't brush. And if you look back at the monitoring of residual plot, you'll notice that there is indeed one blue unbrushed residual, which is slightly greater than the bulk of them.
Okay, let us go again, and this is this one here.
Yeah, that's right.
This one here, right. Okay, now we move to monitoring S estimators. So we use S regression for 50 values of the breakdown point. So this routine calls function sreg, which performs S regression, in this case using the bi-square row function. Now we are going to do the same with using the power divergence row function. In this case it is quicker, so globally we have 50 fits here and 50 fits here. And so the purpose is to understand how the residuals change as the breakdown point change, as the breakdown point goes from 0.5 to 0.01.
So that is as the regression goes from being very robust to very slightly different from these squares.
Okay, so we wait for this process to finish, and then we show the monitoring of residuals.
How much more of a process have we got to wait for?
No, probably 3 or 4 seconds.
I see. So you might like just to look at the difference in the times from the two methods.
Yeah, because the power divergence is quicker. Now, on the other end, as you are about to see, the results of these two sets of residuals are very, very similar. So, this is the monitoring of the scaled residuals using the two-key by weight. On the right, we have 3 measures of correlation, because the goal is to understand when there is a change in the fit. And you can see from this candle measure that around 0.15, 14, there is a change in the ordering of the residuals. That is around here. You can see that there are a lot of trajectories that have large positive values, then they all tend to decrease. Vice versa, there are trajectories which have a residual that increases.
So before you continue, Marco, just look at that plot on the right. In the book, there are 3 dips, but in this one, the Spearman and the Pearson do not have dips.
Well, it depends on the scale that you use. In fact, in the book, we used a scale which was very, very close to 0.99. So, there is indeed a dip, but here we wanted to have the same scale. Scale for all the 3 panels on the right. So on the other end, in the book, you will see with different scales for these 3 panels.
So if somebody wants to reanalyze the data, they could plot these with their choice of scale for the different correlation coefficients. Is that right?
Exactly.
Okay, very good.
Exactly. Okay, now we are also going to show the residuals which come from power divergence. So we just to show that well, if you use power divergence or 2q by weight, the results are virtually indistinguishable.
And the change, the dip in the correlation, the change in the correlation occurs at what, 0.13 perhaps?
Something like that, something in between 0.1 and 0.15. Now, we now go to the monitoring of the T statistics as a function of the breakdown point. Let us. This plot uses the same scale for in all panels.
This is probably more useful than the plot in the book, in which the panels have been automatically scaled. You cannot really tell so easily which variables are significant, which are not significant, and which ones have significance that change as the outliers enter the subset used in fitting.
And now notice, for example, T6 and T10. The final value of T6 and T10 is almost the same. But on the other hand, these plots suggest that while the value of T6 is always close to the upper confidence band, the value of T10 was much more significant throughout. And then at the end, when the breakdown point is small, then its significance starts to decrease. Moreover, it is interesting to see, for example, to compare T9 with T11. T11 has a value, this explanatory variable has a value of the T statistic which is always negative and significant. On the other hand, the value of T9 was marginally significant and positive. Then it becomes significant but with a negative sign. So you can see that the power, this is what we call the power of monitoring. You can appreciate and analyze how the significance of the explanatory variable changes as the breakdown point changes. And now we repeat the same thing, but now we show the monitoring of the T statistics as a function of the subset size.
From the forward search.
From the forward search, right. Well, you can see that the results are very similar in that, for example, look at this T6. Also, the search suggests that as the subset size increases, these T statistics always is positive and significant. On the other hand, look at T9. T9, we saw this change in sign, and this is exactly what happens when you do the monitoring with the forward search. Or, for example, look at T10. T10, the significance of T10 decreases. Here we have put also a vertical line in black color, because this vertical line is at the point where the automatic outlier detection procedure based on the forward search starts detecting outliers. And here you can see that on the right of this vertical black line, there is a change in some particular t-statistics.
but not in all.
Not in all. So once again, we are able to understand from a particular point onwards what is the effect of a potential group of outlying observations.
So this is nicely, these curves are nicely summarized in the monitoring plot of the 13 added variable t-statistics. Here we are. These added variable t-statistics actually have t-distributions, so they are slightly different in detail from the ones that we've been looking at before, which are were just calculated as the search or as estimation proceeds. But they very clearly show, and this is the main point, they very clearly show that something significant is happening at the point at which the outliers are starting to be detected by the automatic procedure.
Right. So you notice that their significance tends to increase as units from the same population enter the search. On the other end, you can see that beyond a certain point, their significance decreases. This is once again an additional signal that there is the sample is not homogeneous, that there is more than one population. One can run our automatic procedure for outlier detection, and the number of outliers which are found is 255. And here from the plot, which has two separate symbols for these two populations, shows that generally the outlying observations, apart from these these largest outliers that we have seen before, here the data contain two populations. So these are the most active customers, those shown in blue. In fact, here the outliers is not something in this case to remove, but to understand that you have divided your set of customers into two groups, these two groups that...
Just for clarification, the most active customers are in fact in red, aren't they? And the less active customers on this plot are in blue.
In the book, then, there is a detailed description why these two sets are different. So we give a detailed analysis and hope you
feel that this is supported by the data and helps you to understand its structure.
Okay. Thank you for watching, and see you to the next...
Yes, lots still to come.